Hi, welcome back to another episode of Algebra and Words, the video series on YouTube. In this video, we're going to continue our discussion on factoring polynomials. And mainly, we're going to be focusing on factoring four-term polynomials like this, in which we're going to be using the grouping method, factoring by grouping. So before we get to this one, and it's a very easy method, let's take a look at two things above that are going to segue into the principle of factoring by grouping. So first of all, let's look at the top polynomial. It's a binomial, 3x squared plus 12x. And all we have to do here is factor out and look for a greatest common factor. So all we're doing for this is looking for a greatest common factor, and in that case, it's 3x. So we're going to just factor out the 3x, and then in parentheses, write what remains after we divide each term by the greatest common factor, 3x. So 3x squared divided by greatest common factor, 3x, equals x. That goes here. And 12x divided by 3x equals 4. That goes here. And that's the end of that problem. Now, let's look at the next one. And once again, it's to look for a greatest common factor among the terms. Now, compared to the top one and to the next one, what I have here to demonstrate is that in this one, a monomial is the greatest common factor. But you could also have a group that contains multiple terms, like a binomial. A group, that's why I have it highlighted in red to show you that this group and this group are the same, both multiplied by another factor in its term. And so this is to demonstrate that, basically, in summary, a binomial group can also be a greatest common factor. And when it is, you factor it out just like you did with this. So first, write the greatest common factor, the group 3x minus 2, and then another set of parentheses to put what's left after you divide each term by the greatest common factor. So if we think of, and you don't have to do this every time, but in the beginning you might want to do it, is to actually divide the greatest common factor out. And that cancels out that entire group, leaving 5x, which we write in the parentheses. And then do the same to the next term. Divide out the greatest common factor, which is the group 3x minus 2. That cancels out those both groups, and leaving just the 2, which we put here. And make sure you keep the sign. So again, in this problem, in this expression, it's to demonstrate that a greatest common factor can also be a binomial group, and when it is, you treat it like a greatest common factor by factoring it out, and it will ultimately look like this, two binomials multiplied together. So that's kind of a key thing to recognize, because if you see this at the end of factoring by grouping, especially when you're given four terms like this, then that tells you that you're probably mostly on the right track. So now that we know factoring a greatest common factor binomial out, that leads us to this, the four-term polynomial. 2x cubed plus x squared plus 2x plus 1. And what we have here is we have basically another step that we need to figure out to determine if there's a greatest common factor binomial within these terms, similar to the last problem, which is, you can think of this problem as sort of one or two steps are already done for you, exposing the greatest common factor group. But in this case, we have to find it if there is one. So this is the method that we're going to follow. Please follow it very carefully because the details matter. Here's what you're going to do. First of all, always make sure that your four-term polynomial, or really any polynomial, are in descending order. Highest exponent down to the lowest exponent, which in this case it is. Secondly, you always want to look for a greatest common factor, a monomial greatest common factor. And in this case, there is not one. So the next thing that we're going to do is we're going to put parentheses around two pairs of terms. First, the left pair, like this, just put parentheses around them. And next, put parentheses around the last two terms, but always make sure to keep this sign inside the parentheses like this. And always put plus between. you must always put plus between. If you forget the plus between, it'll look like a binomial times a binomial. It's wrong, it'll get confusing. Okay, so you need to set it up like this. Parentheses around the first two terms, parentheses around the last two terms with the sign inside. That matters especially when this is negative. And always plus in between no matter what. Now let's go to the next step. The next step is going to be, so let me prep you for what we're going to be looking for in the next few steps. Once we have the parentheses, we're going to be looking for a greatest common factor of this group only, a greatest common factor of this group only. I call them mini GCFs because they only apply to each group. And then, once we factor the greatest common factor out of this group and of this group separately, then we're going to look to see if we find a greatest common factor binomial, which then, if we find one, we can factor it out later. So anyway, looking at just these two terms, is there a greatest common factor? And I would say it's x squared. So let's go down and factor it out. So x squared comes out in the front, and that leaves us with 2x plus, and x squared divided by x squared is 1, so it leaves us with 1. Now let's go to the next group. Put plus, and again the question is there a greatest common factor between these two terms? And in this case, there's not. So we're just going to rewrite 2x plus 1. Okay, now let's pause and just look at the problem, and you want to look to see if anything jumps out at you as being the same. Basically, at this step, a greatest common factor binomial. So hopefully you clearly see that this group 2x plus 1 is the same as this group 2x plus 1, and this is now our next and basically last greatest common factor among this whole expression, and this greatest common factor happens to be the binomial, just like in this demonstration. So what are we going to do? We're going to factor this out of this term and this out of this term. And it's going to look like this. Let's put our parentheses and let's write out our greatest common factor like this. That's this and this. Then another set of parentheses, which we're going to put two more terms. And it's going to be the factor outside of this, which is x squared. And then, is there a factor outside in the front of this factor? And you should say, yes, it's the unwritten factor of coefficient 1. So we'll write plus 1. Very important that you remember to put the 1, even if this looks like it's alone. And the way to think of it is again, if you divide each term by the greatest common factor, then this divided by its greatest common factor, anything over itself, is 1, which is why we have 1. So that's the intro to factoring by grouping. I am going to go over more examples of factoring by grouping where there are a few other little nuances like negative signs and some little situations where you have to do some rearrangement, some things that you might see on a test. But I'm going to stop the video here because I think that was a good intro to factoring by grouping. One final thing is, what's the purpose of factoring by grouping? Well, later, and I'll post them in later videos, when you get to factoring trinomials and quadratic equations, there's a method called factoring by the AC grouping method. Half of that method, it's the latter part of the method, utilizes factoring by grouping. The earlier steps of that method I will demonstrate in its own video, the AC grouping method, which you can find in the links below. So anyway, thanks for watching, and I hope you found this helpful. Please leave any feedback in the comment sections below. If you did find it helpful, please give a thumbs up. Please share with your friends. Please subscribe to the channel and click the little bell sign so that you can be alerted the instant that new videos are released. And also check out related content on Facebook and Instagram, and I'll see you in the next video.